name is Galletta, and I have been working with Dr. Patty Jones this summer and fall, and I'm looking at the impacts of specialized milkweed herbivory on monarch oviposition or egg laying in the field. So just as Anne's pulling this up, I'll just kind of start going and then we can get the visuals. Oh, there we go. So, and why don't we go to the monarchs and milkweed slide? And you can click 3 times, get all my pictures up there. I've got a bunch of animations, so awesome. So this year I was lucky enough to spend my summer with a few of my favorite species, so the monarch butterfly and their native local host plant, common milkweed. And so milkweed is the only food that monarchs can eat as caterpillars, and it's so important for young caterpillars to have access to milkweed that females lay their eggs directly on its leaves. So here we've got a picture of the iconic monarch caterpillar at the stage right before they're going to make the chrysalis. And next to it is a newly hatched monarch next to the egg. So the scale here is a little bit misleading because the little one is actually barely 5 millimeters long and around 1/2000th the mass of this big one here. So in the weeks in between these 2 stages, all monarch caterpillars are eating milkweed leaves. But milkweeds have developed some defense mechanisms to deter herbivores. So one is milky latex, which is the thick, sticky white substance that's found in the leaves and stems of the plant and that the plants are named after. And milkweeds also produce a group of toxins called cardenolides, which can be found in all parts of the plant from the roots to the flowers. So for unspecialized herbivores that try to eat milkweed, the effects of these compounds can range from a very unpleasant bitter taste to cardiac arrest and death. However, monarchs have evolved to become milkweed specialists, and while high levels of cardenolides can slow their early growth, older caterpillars can effectively sequester the toxins into their own bodies to become distasteful to their predators. Next slide, please. So monarchs aren't the only insects that do this though, and there's actually 10 other species in the Northeast that have convergently evolved to eat a diet of only milkweed. So these species are pictured here, and we've got 3 beetles, 2 seed bugs, 1 moth, 1 leaf mining fly, and 3 aphids. So the fact that there's really only 11 insects that eat milkweed around here makes milkweed herbivory a pretty approachable study system. Each species has a distinct way of feeding on the plants, so if you know what to look for, it's relatively easy to determine which species cause damage to a leaf. Next slide. So for example, here we've got damage from 4 common specialist herbivores, and they're all pretty distinctive. In light of these different feeding behaviors, it's really interesting to look at herbivory-induced defense. So induced defense is the process where a plant responds to the physical and chemical cues from herbivory damage by increasing its defense mechanisms. And if you click, we can get my sources for this stuff. So all common milkweed plants are going to have some baseline level of both latex and cardenolides, but herbivory can initiate a temporary increase in the production of both. And then these responses will hopefully deter other herbivores from eating its tissues. Research has shown, however, that herbivory by different species on milkweed can even induce different defenses, which can lead to a cascading effect on the herbivores that choose to consume the plant later on. Next slide. So understanding this process, I was interested in looking at the effects of herbivory within the milkweed insect community and seeing how it impacts monarch egg laying decisions. Since young caterpillars can't leave their host plant for almost a week after hatching, females have to choose their oviposition sites wisely, and I wanted to know whether the presence of herbivore damage on milkweed plays a role in these decisions. Click. So Dava Holloman, another student working with Dr. Jones this summer, also graciously allowed me to use data she collected looking at general herbivory damage and flower visitation by nectar-eating insects on milkweed. So this allowed me to examine how the extent of milkweed herbivore damage may also impact insect flower visitation and subsequently pollination. Next slide. So in order to test this in the field, I collaborated with dozens of conservation commissions, environmental groups, and private landowners to locate 33 milkweed fields throughout southern New Hampshire, and I conducted a total of 59 milkweed surveys. And click, and then we'll be able to see, so Dava's pollinator surveys were conducted in central North Carolina across 9 sites, primarily in state and local parks in the Raleigh-Durham area, and she did a total of 90 surveys. So for each plant within my survey transect, I measured its height, counted the number of leaves damaged by herbivores, identified the herbivory damage to species as best I could, and counted the number of seed pods present. If you click, we can take a look at what little tiny monarch looks like again. So I also looked at every leaf on these plants to find and count the number of monarch eggs and caterpillars. So again, these guys are super tiny. That is my thumb for scale next to a very newly hatched baby monarch. So for the purposes of my data analysis, I grouped eggs in these very young caterpillars together, since at this size, they don't really leave their host plant. And so this allows me to increase my sample size while also still using them as proxies for where a female monarch decided to lay an egg. And click. So in North Carolina, for each plant within the transect lines, the number of leaves damaged by herbivores were counted, although not identified to species. And for plants that were actively in bloom, the flowers were watched for 90 seconds to count and identify the nectar-eating insects. So now let's take a look at what I found. So there we go. To examine the impacts of herbivory in several different milkweed, physical milkweed parameters on the number of monarch eggs laid per plant, I ran a generalized linear mix effect regression with site and date as my random effects. So there on the y-axis are the fixed effects I included in my model. And this plot basically just shows the strength of these predictors on the number of young monarchs found per plant. So first we've got the presence of herbivore damage, excluding damage from young monarchs. And this shows us that on plants that had any amount of herbivory damage, there is an average of 0.3 times as many monarch eggs and young caterpillars than on plants with no damage. So if you flip it, another way to think about this is that on plants with no damage, there were 3.3 times as many young monarchs. So then next we've got milkweed density, and this shows us that there are 0.67 times as many monarch eggs and young caterpillars found on milkweed and transects with high density than in low density. And finally, give it one more click. And I also included the number of seed pods and the height of the milkweed, but neither of these had a significant effect on the number of young monarchs I observed. So if we go to the next slide, we will see a graphical depiction of another generalized linear mix effect regression, this time examining the number of insects that visited flower and milkweed with leaf damage. So again, this model was run with site and date as my random effects. And basically what you're looking at here is each black point represents one milkweed plant. So that's plotting out my raw data. And then the blue regression line shows the model's estimates plus and minus standard error. So as you can see, milkweed plants with more damage received fewer flower visitors than plants with less damage. So now let's situate my findings in the broader context of milkweed research. So in experiments where plants were grown and experimentally manipulated in trials, it's been shown that monarchs prefer to lay eggs on younger plants. And this is because they're more tender and nutritious for caterpillars than older senescing leaves. In my study, I accounted for this by counting seed pods, since only older plants that have been successfully pollinated will have seed pods on them. However, the number of seed pods is not a predictor of young monarchs in my model. So then if you click again, we see monarchs have also been shown to prefer laying eggs on tall plants. And this is probably because tall plants are just going to have more leaves and therefore more food in general for the caterpillars to eat once they've hatched. Again, though, this was not a predictor of young monarchs per plant in my model. Next, we'll see monarchs lay more eggs per plant in patches with lower milkweed density. So this one's not a preference per se. It's just that at higher densities, there are more available options for the monarchs to choose from, right? There's just more plants in general in the same amount of area. So there are fewer eggs per plant when you average it out. But this explains why milkweed density was a predictor of young monarchs per plant in my model. And then finally, it's been demonstrated that monarchs prefer to lay eggs on plants with intermediate levels of cardenolides. So this suggests a trade-off between a female selecting a nutritious food source that allows caterpillars to grow quickly versus one that's going to provide them with enough toxins to sequester for their own protection against predators. So this is really interesting because in my model, the presence of herbivore damage had a very strong negative effect on the number of young monarchs per plant. So although I didn't directly measure plant chemistry, this result would suggest to me that milkweed with less damage and thus a lower cardenolide concentration was preferred because herbivores are known to induce higher cardenolide concentration. However, another study found that the number of damaged leaves observed in the field and cardenolide content weren't actually very strongly correlated. So it's possible that this trend that I saw was maybe driven more by induced latex production than cardenolides, since they are controlled by different mechanisms. Our flower visitor data tells a slightly different side of the story, though. So unlike latex, cardenolides are found in all parts of the milkweed, including in the phloem and the nectar. So when herbivores forage on the leaves, they can increase cardenolides throughout the whole plant. So my model revealed that higher levels of previous leaf damage predicted lower numbers of insect flower visitors on blooming milkweed, and this suggests that the damaged plants were distasteful to visiting insects. But the concept of distasteful nectar is really interesting because typically we think of plants producing nectar in order to entice insect visitors with a sweet meal in the hopes that they get pollinated. So in this case, milkweeds face a trade-off between defending their photosynthetic leaf tissue from herbivores and providing potential pollinators with a yummy, low-toxin reward. So it is possible that maybe the most effective milkweed pollinators have a higher tolerance for cardenolides or somehow otherwise benefit from consuming them in ways that we still haven't fully parsed out yet. But it's also possible that as a perennial plant with underground rhizome networks, maybe milkweed just doesn't need to prioritize pollination as much in order to still be successful. So this is a really fascinating ecological question that definitely warrants further study because there just hasn't been very much work done on this. In my study, though, as I continue to work on this project, I want to keep looking at my data to really parse out relationships between specific herbivore species as have been observed in past experiments. So for example, it's been found that damage from monarchs and milkweed stem weevils seem to be disproportionately strong deterrents for other species later in the season. But these results were found through experimental plant manipulation. So I'm hoping that my efforts to identify each type of damage in the field will allow me to compare overall trends like this without having manipulated any of the milkweed like other studies have done. So I, of course, for all of this, need to thank my advisor, Dr. Patty Jones, who has just been an incredible help all summer and fall, as well as Dava Holloman for allowing me to use her summer survey data. And I have so many people to thank. I know some of you are here today, but I worked with a lot of people at home in New Hampshire over the summer to locate sites. I had 2 people come out and take photos of me for science communication pieces, which you've seen all of the beautiful pictures in my presentation today. So just a huge thank you to everyone I worked with this summer. And then I also just need to recognize and honor the fact that this research was conducted on Indigenous lands. In New Hampshire, I was working on the traditional territorial lands of the Pennacook and Pentucket peoples of the Wabanaki Confederacy, and Dava's work was done on the lands of the Tuscarora and Shakori peoples in North Carolina. So with all of this gratitude, I'd finally like to thank everyone for coming to my talk today. Again, apologies for the technical difficulties. Glad we could figure it out, and thank you so much, Anne, for taking care of it for me. And yeah, let's open up the floor for questions. Thank you very much.